Hi everybody. Today we're going to be talking about relative extrema and critical numbers. In calculus, a lot of what we spend our time on is trying to figure out the behaviors of functions on a graph. And so one of the things we're going to work on today is using the derivative to determine whether there are minimums and maximums on the graph of a particular function. We're going to be looking at both closed interval and open interval parts of a function. So the min and max of a function on an interval, a closed interval, are usually called absolute mins and maxes. So let's just say, looking at this quick sketch, we have a closed interval between -2 and +2. You see the graph is continuous throughout. This here would be considered our absolute maximum because there's only one maximum in the picture within the interval. So we would call that an absolute max. Here at 0, 0, you would call that an absolute min. If you had a graph that looked like this, you would have multiple mins and maxes. So we would call these lower ones a relative max, and the biggest max would be an absolute max. The same would go for the mins. Actually, these would both be relative mins because of the way that the graph has arrows pointing off to negative infinity on both sides. But these two dips that go down would be relative mins. Using the values of the function's derivative at each of the relative extrema, we can determine what the critical numbers are for the function. So say we had the function of x to the fourth minus 4x squared plus 4. And we took the derivative of that function. We get 4x cubed minus 8x. If we then factored, let's see if I can get rid of that. If we then factored this derivative, it leaves us with this product. And we could use the zero product property to set each piece of this product equal to 0 to solve for the values of x. These values will be our critical numbers for the function. So x squared equals 2, x equals plus or minus the square root of 2. So the critical numbers for x to the fourth minus 4x squared plus 4 equals 0 and plus or minus the square root of 2. What if we had the function x to the fourth minus 2x squared, and we set this function within the interval of -2, 2? If I were to take the derivative of the function, I would get 4x cubed minus 4x. And then if I were to factor the function the way we did with the previous one, I would get this product for my solution. Using the zero product property, the way I did in the first example, and I solved this factored equation, and I got x equals 0 and x equals plus or minus 1. So these are 3 critical numbers that have to do with this function. we're going to evaluate the function based on these three critical numbers, but also we're going to take a look at these endpoints as well, because the endpoints can also have values of mins and maxes that are involved. So we're going to make a little table endpoint, and we're going to check the function for each of these with when the value is -2, when the value is -1, when the value is 0, when the value is +1, and when the other endpoint is +2. So I've already evaluated these, and I have come up with the fact that f of -2 and f of +2 are both +8, f of -1 and +1 are both -2, and f of 0 is 0. So if you can kind of imagine that these are our y values, you know that there are y values, that what I'm seeing here is these two 8s, the biggest numbers we have, these are the maxes of the graph. And this -2 and -2 relative mins are going to occur here. And so I'm going to assume that since it's a max to a min, that there's got to be a max, a relative max at 0. Obviously it's not going to be as high as these two maxes, but there will be a bump there. So if we were to take a look at what that graph would look like, I'm going to make just a quick sketch here of, this is -2,8, +2,8. There was a point at 0, 0, and there was a point at -1, -2, +1, -2. So this is sort of going to look like a W, and smooth curve, and we're going to assume that this is curving back around this way up there. Not exactly sure, but that's what it would look like. So notice that these are maxes. Let's change the color here. The maxes in the graph, and these are the mins in the graph. And this is also a max because it's a, we said peaks and valleys. These are all relative maxes, and these are all relative mins. So I think you sort of get the picture, no pun intended. I hope you'll try these on the problems that I assigned to you today. Thanks.